Okay, so I think this is a good point to stop on the encoder. So before moving on to performance, I just want to go and clean up a few things in the encoder code. So we'll just have a look through these. So for example, I think this operand decorators doesn't actually have all of the decorators in here anymore. So basically an operand kind is something that we can match on for a form, whereas a decorator is more just about validation or different behavior within the emits function. So we'll just take some of these out that can't be matched on. So for example, reg low and high can't be matched on. Same goes for SP and BP memory. I think all of the RM ones are matched on. No base and scaled index isn't. Disp isn't either. Immediate is matched on, and so is I1. So I think it's just these ones. So if we just take these and OR them together, maybe we'll just group some of these together as well. Op masking zeroing, these ones can go together. The segments can go together. And I think that's okay. Let's just run a test. Okay, that's fine. So we'll carry on down here. I don't know which immediates are actually used. So we've got im8, which is obviously used. im16 is not matched on at all. 32 isn't, and 64 is. So I guess we can get rid of im16 and 32. So we'll just delete these ones. Oh, that was 8, 16, 32. Let's just remove it from here as well. Okay, that's fine. So memory, when we're modifying something for memory, I should be getting rid of all of the register flags here. So we'll say get rid of all of these. Let's just all these ones together and rerun the test. That's fine. Segments, it might be nice to group these into, for example, seg, we'll just say. Like that. Maybe we'll put requires evex on the end. So if it's not any of the segments, then we must provide the segment override. Or if it is any segment, we've already got a segment override. It must be memory, so that's fine. In SI, if index is requires evex, because this could be an operand being passed in that's like, for example, a vsib index that's a high 16 register. We need to basically bring that flag over to the new operand. So info or equals requires evex. I think disp is okay. K is probably okay as well. This has requires evex, so that's fine. Zeroing should also require evex. Same goes for SAE. And ER and broadcast, they all require evex. Okay. Let's carry on moving down. Okay, I think I'll handle form scoring in performance. I probably don't actually need to do any of this anymore. This could be taken over to the operand's match function, so I don't have to just guess based on operand 1 or 2 or whatever. But I'll do that in a minute. This is fine. Rex, form.rex could probably be merged with form.w. May as well put this switch into if rm is any of segment. There's no point in doing any of this if it's not a segment in the first place, or segment override. Let's see, legacy, we'll leave the switch how it is there. vex seems mostly fine, evex prefix seems mostly fine. Okay, we've got this vsib check where we try to keep the mod as address indirect, otherwise change it to disp32. I think I can probably just invert this and get rid of the else here. Yep, that's okay. Tuple types. I don't actually have all of the tuple types right now. I've just got full mem and tuple1 scalar, so maybe I should just go and add those even if I don't actually use all of them just yet. I think this was in the evex prefixes section. If we go down, yeah, here it is. So we've got full and half. So let's just add half. So we've got full mem. Then we've got half mem, quarter mem. So this is half mem, this is quarter mem. We've got eighth mem. Yeah, okay, so eighth mem. There's mem 1 to 8. And there's mov dedup. Then we've got tuple1 scalar, tuple1 fixed. So these ones, I guess I'll just put them up here like this, so then in the same order. So we've got fixed. Full mem was up here. Then we've got tuple 2, and tuple 4, and tuple 8. So out of all of these, if it's not full mem, and this should be elem here for the element width, but it's not really if it's full mem. Any of these memory ones can be, any of these memory ones, the element size or the scale can be derived from the width. Because if it's half mem, it's just width divided by 2. If it's quarter, it's just divided by 4. So we don't actually need this for any mem ones. So maybe we'll just keep all of these mem ones together. And let's just have a look at, so 1 to 8 is 16, mov dedup is a special case. Yeah, so all of the memory ones, so if we just say if it's from, if this is, if it's anything that's not one of these, basically. So if form tuple is less than this, or if form.tuple is greater than this one, let's just group those together, and then element is 0, then we would panic because we require the element width. And I could probably move this into a test for forms, really. Then I wouldn't need to do the check here, but we'll take that out a bit later, maybe. So we've got full and half. We'll say panic. Actually, there's another panic up here which I could probably improve, which is unsupported op-n. We'll say format dot sprint f. We'll put the name of the unsupported op-n in here. So this will be op-n names, and we'll just do form.op-n. So let's find op-n. We'll copy all of these ones into op-n names. Okay, let's give each of these a name string and get rid of op-n from the beginning. So that's one panic there. Another panic is just could not match instruction form. We'll leave that for now, that's fine. So form is missing element width. I think that's okay. So here we can just say unhandled. Let's see, unsupported should probably be unhandled as well. So we'll say unhandled tuple type. Unhandled, yeah, we'll just say unhandled tuple type and give it a name. So this will be tuple type names. Yeah, tuple type names. Okay, let's just go into here and we'll do var tuple type names is equal to a static array of strings. And we'll just give each of these a string name. Get rid of the word tuple on the beginning. Actually, we'll keep tuple. We'll give them the same names as these. So this is just full and half. This is tuple1 scalar. These ones here are just full mem, eighth mem, etc. Then these ones are mem128 and mov dedup. This one needs to be a format.sprintf. Is there anything else down here that needs cleaning up? I think that's probably okay. Let's just do a test here. Okay, so that seems fine. Okay, so if we go to the tests now, we could do a function for test. Let's say we'll test tuple type forms or something like that. So this will be testing.t. And here, I think what we want to do is basically go through all of the forms. So we'll say for mnemonic. Is this mnemonic? So we've got forms. So we've got a mnemonic with a forms table, basically. So this is forms, range over forms, and then we'll range over, we'll say I form, or we'll just do F, range over forms. Then we can do something like saying, for each of these forms, let's go to the encoder and we'll get these things. We actually only need RM, I think, for this. So let's just go and take these. So we'll figure out what RM is here. So that one sets RM. This one is setting RM to op1. Yeah, op1. This one sets it to op2. This one is also op2, so we'll just add this over here. This sets it to op1. These ones actually also set it to op1 up here, so we'll just combine these. That was op1. This one is setting it to op2. This one sets it to op3. And then this one is also op3. Okay, so let's just clear these out. So we've got a switch here. Okay. So what we'll do is say if the form family is not evex, then we'll just continue because evex is the only one that can have tuple types. Then what we'll do is say if RM isn't memory, because these tuple types only apply to memory displacements, then we'll also continue. Then we'll say if the forms tuple equals tuple NA, which is the 0 value, then we'll just do a log. We'll say t.log f evex form with rm memory operand missing tuple type. And what we'll do here is we'll have the mnemonic with the index of the form. So this will be mnemonic names, and we'll put the mnemonic in here, and then we'll do the index here. So let's just try and run the tests. Undefined form. Undefined form. Okay, yeah, this needs to change to F. And then op1. Okay, let's see. So this shouldn't be operand, this should be flags. So instead of assigning just op1 and op2 and things, we'll do, this will be f.op whatever. Okay, let's run verbose. Okay, so now I can see all of the evex. I need to spell evex correctly. So now I can see all of the evex mnemonics with the index of the form that's missing a tuple type. I'm not actually going to add these now because there are quite a lot of them, and adding them only improves the size of instructions emitted with a memory displacement if it happens to be a multiple that can fit within a disp8 in the compressed evex disp8. But if I just always fall back to 32-bit displacement, that's still correct as far as the encoder goes. So I'll leave these just as like an informational test that I can come back to later if I want to. But we should also test just forms in general. So I think for this one, we will just keep the same sort of loop. But here I want to make sure that I've actually got sort of like the correct things in the forms. So for example, we can say if f.opn equals opn unknown, then we should do like a fail f or something. Maybe what we'll do is we'll take the this sort of mnemonic with the form index. So we'll just put this up here as like a name. So this will be format sprint f. So we'll create this name to use in sort of like failure messages. Oh, this is fail, or is it error? Error f, I think. So this will say, for example, unknown op n, and then we'll just put the name. So that's a failure. So if we do the test, none of them should be failing. In this case, so that's fine. But if it was something else, like if we said O, then we get to see which ones have the invalid op n. So that will just help me to add forms at a later time if I want to. Width should also be set. So if the width is 0, then we'll put 0, or we'll put no width set for this one. We'll also want to make sure that we are only using width bits in the widths for, so that will be for width, enc width, and lm, I think, for the tuple type element width. So maybe what we'll do here is we'll just say const widths will be, well, let's just go to width here and just copy them. So we need to basically make sure that we've got only these bits. So, you know, this isn't really like a case where it's going to break anything, but I'd rather not have just these silent things in forms that don't actually do anything. So we'll say, for example, if width is 0, then we do that. We'll also do enc width is... enc width actually can be 0, so that's fine. What we'll do then is say if, okay, we'll get to the tuple test in a minute. What we'll do for width is say that if f.width and not widths, so this will unset all of the width bits. If this is still not 0 after that, then it means that we've got invalid bits being set in that form. So we've got invalid width bits set for that one. Let's just test, that's all fine. So for example, if I go to forms, and let's say for lock here, I put some other thing in, let's just say it's like 0x, I don't know, 1, 2 or something like that. That's fine. I've let's say 0 plus 1. That's still working. 0 plus 1. Okay, so this must be wrong then. If width is set, okay, width has all of these things. 0 is the top one there. Oh, I need to shift it over 1. And now it's going to complain. Okay, let's go to 0 here. So we've got bytes. We've got 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. I guess this is always going to be fine then, so maybe I don't need that check after all. So we'll go back and just remove that. Or actually, I'll keep it just in case the representation changes. Okay, well that should do it. If the width was bigger than a byte, I think it would do it. Okay, so that is widths. For enc width, I think I'd want to do the same thing, but only if it was set. If enc width is not 0 and we have some unknown width in there, let's just go to width again. If I change this to int, and then go back to forms, I just want to see if this does work. Yeah, okay, it does work. So invalid width bit set in lock because I've done one that isn't part of the set of widths that I've said is okay. Okay, let's just go and change that back to bytes. Okay, so that is enc width and everything. Enc width should also only be one of the widths. So if enc width is set to, for example, Q word or D word, that would be invalid. It should only be one width. So we'll say if bits.ones count of f.enc width is greater than 1, we'll say too many enc width bits set. Let's see, uint in, okay, this needs to be 8 maybe, because this is a byte right now. Ones count 8. Okay, that's going to be uint 8. Okay, well, let's just change this to uint. Okay, so let's look for forms. If we put, let's go to find an enc width here. We'll do y word or z word. So we failed this because I've broken the encoding, but also too many enc width bits sets for this instruction and this form. So that's working fine. So that's enc width. We'll probably want to make sure that there are contiguous operands as well, and I think each of these other tests will mostly involve operand, like checking that attributes are okay. So Yeah, okay, what I'll do then is I'll have operands can basically be a fixed array of f.op1, op2, 3, and 4. Then we'll do 4, or actually I can just do this directly. We'll say 4, maybe we'll just say O range over this. Here what I could do is say, let's have the index, this will be j. So we'll say if j is greater than 0, and O dot, or we'll say if O is not 0, so this is the flags for the operand. So if any flags are set for an operand, and actually I do need the operands as a separate thing here. And operands j minus 1 is 0, then that means that we found an empty space in the operand. So if for example, operand 3 has some flags set, then we expect operands 2 and 1 to also have flags set. So we'll say t.error, we'll say non-contiguous operands. This is not operand, that's flags. Okay, so that's fine. So if we go to, for example, forms, and we change this a little bit to say, well, let's find lock. So if in here we put, for example, op3 as reg, then we find that should say contiguous operands for lock form 0. So let's just get rid of that. Go back to the test. This should be contiguous. Okay. So that checks for gaps in operands. So now I think, so for each form, so we've got an operands loop, which is fine. We've got a tuple check here. We'll do a couple more checks on the form itself. So we'll say, for example, we'll do a switch on form.op_n. We could put this into a case over here. So in the case that it's unknown, we do this error. In the case of op_n, or actually no, this isn't op_n, this should be family, so actually we'll put that back up there. We'll switch on family. We'll say case legacy. In this case, if the form's width is, if it is one of the widths, y word or z word, we'll say legacy cannot encode y word or z word. And for vex, we need to do the same thing, but only for z word. We've got form in here again, so f. Okay, so actually I have got some incorrect forms here. So this is, these ones need fixing. So vex here can't use z word. Same goes for this one. And this one. And this one down here. Looks like this one's got it as well. Let's see, did that get them? Yep, that's all fixed now. So that's just some width checks. If it's legacy or vex, then I need to make sure that we're not encoding anything that would be a requires evex. So if this would be in the operands though. So we'll do a switch on family in the operands here. So in the case of legacy, we'll do a check for saying if O dot is any of opmask or zeroing or SAE or ER or broadcast. I think that's it. If it's any of those, then we'll say that we can't. Let's see. Legacy cannot encode evex attributes. And we can do the same for vex as well. Okay, and we've got some here that need fixing. So VP gather DD. Vex cannot use opmask. You can use vsib, so that's fine. Prefixes is something I'll also need to check. Let's just go and get these fixed up first. Okay, these ones again. So these ones with vex, these ones all have opmask in them and zeroing. Okay, so that's fine now. We should also be checking prefix as well and maps. So legacy is that if f.map is greater than map 0f3a, so if it's map 4 to 7, that can't happen in legacy. We'll say legacy cannot encode maps higher than 0f3a. And we'll do the same thing for vex as well. But vex actually can't encode the primary map either. So in this case, we'll do if map is equal to map primary, then vex cannot encode primary opcode map. That's all okay. The same goes for evex with the primary one, I think, because in the prefixes you have to choose one of the maps that's not primary. So in the documentation here, for example, in the prefix for this, the maps here are 0f to 3a. I think the same thing goes for evex. Let's go have a look at evex. Map. So MMM supports 1, 2, 3, 5, and 6. Yeah, where 1 is actually the secondary, 2 is 3, 8, 3 is 3A, and then there's 5 and 6 as well. Okay, so what we'll do then is say evex if it's primary, or if it's 4 or 7. We'll just do a switch on the map here. We'll say case primary map 5. Oh no, not map 5, map 4 and map 7. Primary is 0. So evex cannot encode primary opcode map primary 4 or 7 opcode maps. Okay, that's fine. So that's a map check, but also a prefix check as well, because the prefixes here that are supported is identical to vex.pp, and this one is 66 F3 or F2, but there is 67, which is used in legacy. So this one also should be saying that if prefix is equal to prefix 67, then in this case this is vex cannot encode prefix 67. Same goes for evex. Okay, that would have failed anyway with some encoding problems, but just another thing to help. Legacy can't encode vsib. So here we'll say, actually this one, these map checks should be outside of the loop here. This one should go up to, well, let's put family up here first. Then we'll put this map check over here. Actually, no, family can go down here. That's fine. This legacy map check should go in here. These map and prefix checks should go into vex here. And then we need a case for evex for the map and prefix checks. Those can move up into here. Okay, so back to operand checks. Let's just run the tests again, that's fine. So legacy, we want to say if O is vsib, legacy cannot encode vsib. Vex and evex can. Some general checks for these things though is that, let's do this after the family thing. We'll say that if O is vsib and O is not memory, then we need to fail because vsib must can only be applied to memory. We'll say vsib requires mem or something like that. Okay, same thing goes for if it's zeroing, then this requires op mask. Yep, that's fine. If we've got SAE and ER, we'll say that SAE and ER are mutually exclusive because they're both just setting the B bit in the evex prefix. That's all okay there. Yeah, so another thing here is that if it's any of vsib or broadcast, that would actually need to be, that would actually require memory. So we'll say broadcast or vsib requires mem. Yeah, that's all okay. Then we'll say, for example, so the tuple type check, if we go to the encoder, we've got dot tuple. I've got this check here for missing element width, which I could take out if I just add it to the tests and just assume that it's correct. So if we take that out of here and put it into here instead, so here we can say that, for example, if form, so this will be F, this is not an operand check. This will just go up here. We'll put it Yeah, I guess we'll just put it here. If tuple is, yeah, okay, form, we'll say missing, so this will be an error instead. And here we'll just say missing tuple element width. Then we would want the inverse of this as well, to say that if the element width has been set, we'll say if this is less than or equal to tuple and this is less than or equal to mem128 and it is set, then we'll say tuple element width should not be set in this case. Okay, so this is saying missing tuple element width. That's because, okay, this should only be if tuple is not tuple NA. Okay, that's fine. And tuple is only applicable to evex anyway, so let's move this into the evex checks. We'll put it up here. And we'll also move this into here as well to say that if it's not NA, then vex can't use tuple types. Vex does not need a tuple type for this one, and we'll also say if lm is not equal to 0, then vex does not need a tuple type element width. Then we can do the same for legacy as well. Okay, that's fine. We can also figure out which operand is which. So for example, if we've got our m here, okay, let's take this whole switch again. And we'll put it into the loop here. So we'll get rid of this one and we'll get rid of the panic, get rid of anything that's not assigning one of these sort of like operand roles. So these will be flags instead. What we want to do with reg, for example, is say, oh, and these should change to, instead of just being op, they should be f dot whatever. Actually, no, they shouldn't. They should be yeah, actually, let's do this. So we'll do f op whatever, and we'll take this out of the loop. So this will be f dot op 1. Yeah. So we'll change all of these. And change all of op3. So this switch can actually come out of the loop. We'll do this before the operands loop. So here we can do stuff like saying if reg is mem, if it's any of these things, so mem or vsib or something, we'll say t.error f mod r, we'll say mod rm reg should only match on register like attributes. Let's say that for now. We'll do the same for vvvv. Maybe we don't need RM as a check in here. Yeah, so I don't need RM right now. Let's get rid of RM from here. Actually, we'll keep it assigned, but we'll just use it. We'll just say that it's like unused for now. And we need to change form. So this is form here and here. Okay, so that's fine. I think maybe we'll just go and look at the operands match function as well now, because right now I'm doing stuff like checking on f.op1, etc. Here I could probably just take this switch. So we'll take the switch, put it down here. And then what we want to do is say, so op1 is op mask. Actually, I think another test to put into here quickly would be that if j does not equal 0, so if it's not op1 and o dot is op mask, t dot error f, just copy this one, we'll say only op1 can match on an op mask. Or we'll say allows. So op1 here is fine. This SAE one, I think we only really need RM, to be honest. So let's just look for, we've got RM as a switch down here. So we'll take RM and just use that as the switch here. So this is f dot op1, op2. Okay, that's fine. So we'll keep op1 as the op mask, and this doesn't need to be here anymore because the test should catch anything that's an op mask on any other operand. This SAE and ER1 is really just for RM. So we'll say if RM, we need RM and RM info. So this would be op2 with f.op2, and this would be op1 with f.op1. Do the same for these ones. This one's op3. Okay, so if we'll do f.op2 is rm info, we can get rid of this op3 check now. Op2 becomes rm. Same thing happens down here. This can now become just rm info. And this could probably be a switch because SAE and ER are mutually exclusive anyway. So actually, if it was a switch, maybe let's just do else if. Let's just keep them separate for now. So then broadcast here, this is also an RM thing. So this is RM info. Don't need the op3 check here now. Then for vsib, if the form operand is vsib, and the actual operand is not vsib, then we don't match on it. So what we also need to do is say that if op1 is vsib and f dot op1 is not vsib, so we just do the same thing but the opposite way. So vsib is sort of like required two ways. So we'll do op2 is vsib and not f dot op2 is vsib. Then we also don't want to match. Let's just do a test because I've probably broken some stuff here. Op2 cannot be used as flags in assignment. So we've got 233. RM, okay. RM is an operand and RM info is the flags. Okay, so that's fine. Okay. All right, well, I think that's probably enough cleanup for now. And I think maybe next I'll look at performance.